Okay, ladies and gentlemen, this is the proof that was printed on the white sheet of paper. So let's just jump into it right now. No better way to learn proofing than just to start writing a bunch of proofs. So we have to prove a couple angles are congruent, EDC and ABF. Now, guys, a three-letter convention naming thing that does get very complicated and could actually be very confusing. So the very first thing I'm going to do is actually rename some angles. So I'm going to call this angle 1, angle 2, angle 3, angle 4, 5, 6, 7, 8, 9, and 10. Now, if you haven't watched my other video, I discussed this more in length, but this is a perfectly okay thing to do in proof. This is your diagram, guys, and you can use the letters I gave you. You can add to it in terms of the name. Like, you can't change what the diagram looks like, but you can certainly change what you're calling parts of it. And for us, if it's going to be easier to say that angle EDC, E down to D over to C, that's angle 5, is congruent to ABF, A over to B down to F, which is angle 10, and try to prove that statement, it might be easier to talk about and write as opposed to getting confused with all these letters kind of getting thrown around here. Let's look at our givens. That's probably important too. Let's go ahead and change it. BAE, B over to A down to E, that's angle 1. So we're told angle 1 is 30 degrees. F down to C over to D, we're told angle 6 is 30 degrees. And ABCD is a rectangle. So how are we going to do this? Well, if these angles are going to be congruent, well, that comes from the measurement. Definition of congruency is measurements the same. So if measurements are the same, it stands to reason they should be congruent. So if I have to show 5 and 10 are congruent, I really just have to show 5 and 10 have the same measurement. Well, how do I do that? Well, look at the given information. This is 30, right? And it's a rectangle. That means this is 90. That's 30. That's 60 because it's at a right angle. Now look, I'm in a triangle. If I'm in a triangle, I know a couple angles. I can use triangle sum to find angle 4. I'm at another 90 corner. I can use that an angle like addition to generate that that's going to be 60 degrees. And this is just like a symmetric part of it. I can work the other way. That's 30. That's 60 because that's 90. That's 30 and that's 60. Hence the measurements are the same. That's our proof, guys. Now we got to actually make that happen. So the very first thing we should do is actually write in our givens. Okay, our given statements are going to be one of our very important parts of proof. It's where we're getting a lot of information and we can derive a lot of information. Allow me to demonstrate. Okay, so I kind of paused there. And I changed screens. That's why you had a sudden kind of shift where you're looking at a full piece of paper. Now you're looking at a smaller one. No big deal, guys. It's just so I have some more room. So let's get our givens into this proof. Okay? So I have this value right here, or this kind of box right here. I'm going to go and rewrite it though. So we have our givens, excuse me, that ABCD is a rectangle. Measurement of angle 1 is 30 degrees. The measurement of angle 6 is going to be 30 degrees as well. And I apologize, that kind of got messy. Okay. Now, this doesn't connect to anything. We don't have to like put an arrow to anything. This is coming directly from the proof. No big deal. But I think we can take this information, namely this piece of information, and derive some things. Okay. Uh, so if I know ABCD is a rectangle, by definition, that means there are right angles. Namely, if I look at angle BAC, or BAD, excuse me, angle, so BAD is this guy, okay? If I look at angle, excuse me, ADC, which is this corner, if I look at angle DCB, which is this corner, and angle DCB, which is this upper corner, they're all right angles. These angles are right. I'm going to write that in. And I know that directly because of the definition of a rectangle. I mean, that's what it means to be a rectangle, that you are a quadrilateral with four 90-degree angles. Um, so that comes directly from our givens. I don't know if we're going to necessarily need that, but I know that comes from our givens. Well, if I know these angles right here are all right, BAD, ADC, BDC, and CDB, DCB, excuse me, I kind of renamed them in my diagram. So maybe I should take some time and rename them right now. So angle BAD should be the same as angle 1 plus angle 2. So in other words, this corner is the same as adding these two smaller angles together. Angle ADC is a result of adding angle 4 to angle 5. Uh, Angle DCB is the result of adding angle 6 to angle 7. And angle CBA is the result of adding angle 9 to angle 10. Now, how am I getting that? Now, I'm certainly getting it from the diagram, but I'm doing something else. Like, that's not directly obvious from the diagram. I would argue I'm using the angle addition postulate, AAP. Angle addition postulate says I can, if I have an entire angle, it's the same as summing the smaller parts of that angle. In terms of connecting this idea, I don't know if I'm really getting it directly from anywhere but the diagram and angle addition postulate, so I'm not actually going to write any arrows anywhere. Now, might that information be important later? Yeah, maybe. I don't know. Maybe I'm doing a little foreshadowing. Maybe I kind of have a sense of what I'm going to need in this proof. Um, but that's something to consider. Like if you know that in the end you're going to need some angle measurements using like the smaller pieces, relating those smaller pieces right away may not be a bad idea. Okay? Um, so, getting into the actual body of our proof, we have to show angle 5 and angle 10 have the same measurement, but we're kind of really starting up here at angle 1 and down here at angle 6. Now, you can probably note that this is just like a symmetric diagram. Like if I'm going to go from angle 1 to angle 2, then use a triangle to get angle 4, then use angles again to get 5, I'm doing the same thing over here. I'm going to use the fact that it's 90 degrees to get 7, the fact it's a triangle to get 9, and the fact it's 90 degrees again to get 10. So I don't have to write this like in two separate steps. I can combine those steps. Allow me to demonstrate. So whenever you're writing a proof, it's very important to keep in mind that you're kind of following kind of like a set order. You have to talk about structure first. In other words, from the diagram, what things do you see? Now, once you know the structure, then you can actually pull a relationship. And a relationship is often going to give you or is an equation. Once you have the equation, then you can actually do your substitution and solving to get values that might help you in the next steps. So that's what I'm going to do here. If 1 is my starting point, I got to mention a structure first. If I don't, then how in the world is how can we prove that's going to be true? So the relationship in this case, I think it has to be the fact that we have complementary angles. More to the fact that angle 1 and angle 2, when combined, are right. By definition, what complementary angles are, they're two angles that add to 90 degrees. Well, if I know that 1 and 2 um, is the same as BAD, and BAD is right, then I can conclude that angle 1 and angle 2 are complementary. Likewise, I can conclude angle 6 and angle 7 are complementary. Okay? How I know that, the because part, the justification part, has everything to do with the definition of complementary. I'm sorry, the definition of a right angle. Okay? Okay? And I would argue that this comes from two places. It comes from this idea that we have a right, and this idea where the two angles create that third angle, where 1 and 2 make BAD, and in this case, 6 and 7 make DCB. Okay? So if I know they're actually going to be complementary, well, I can do something with that. If 1 and 2 are complementary, I know that the measurement of angle 1 plus the measurement of angle 2 is equal to 90 degrees. And likewise, I know the measurement of angle 6 plus the measurement of angle 7 is also going to be 90 degrees. And that's going to be because that's what it means to be complementary. In other words, definition of complementary. Okay. Now, where the idea comes from, well, it comes from the one above it. So my arrow is going to be just single. I'm basically taking the idea of complementary and transforming them into a relationship that I can actually use this equation. Now we actually need to actually substitute and solve. Like the whole point in mentioning this is to get angle 2 and over here to get angle 7. To actually solve for the measurements here, well, that means I kind of have to do something with 1 and 6. But 1 and 6, oh, look at this. 1 and 6 I know are 30 degrees. That's why we started there. So it seems to me we can probably do a little bit of substitution and solving. Hence, that's kind of where the third part comes from. So instead of angle 1, I can write 30 degrees plus a measure of angle 2 equals 90. And instead of angle 6, again, I can write 30 degrees plus a measurement of angle 7 equals 90. And that's just going to be because of substitution. I'm just going to abbreviate, save a little time. You guys are welcome to abbreviate as well. Where the idea comes from, well, I'm modifying the equation above it. I'm also pulling down from my givens. Okay. Now from here, it's just a matter of actually doing the solving. But I can conclude directly that the measurement of angle 2 equals 60 degrees. And likewise, the measurement of angle 7 equals 60 degrees. Okay. And that's just because I'm solving the thing. Okay. And I'm solving the equation directly above it, hence a single arrow. Okay, so where are we now? I mean, so we've now determined that this angle is 60 and this angle is 60. Our goal now is to, excuse me, our goal now is to determine that angle 9 and angle 4 are going to be uh, 30 degrees, and we can use the triangles to actually accomplish this. So we kind of have to start a new chapter. So I'm going to change colors here. Um, so it looks like I have some triangle sum theorem. And again, I'm going to kind of do these chapters together. It makes sense too because I mean, they are basically paralleling one another. They're the same kind of style here. So over on this left-hand side, I can using the triangle sum theorem, I can conclude angle 2 or measurement of angle 2, excuse me, plus a measurement of angle 3 plus a measurement of angle 4 equals 180 degrees. I can also conclude that the measurement of angle 9 plus a measurement of angle 8 plus a measurement of angle 7 is likewise 180 degrees. And that's just going to be because of the triangle sum theorem, which I'll abbreviate triangle sum theorem. Where does the idea come from? Well, it doesn't come from anywhere, really. I mean, that comes directly from the diagram, hence it's going to be nothing pointing to it. I don't think I'm even really using these ideas yet. Um, Now, that is kind of the relationship. The structure is not something I need to mention. The relationship is the equation. Now we're going to our substitute and solve step. Well, we should take a moment here and think about what we're going to substitute into. Okay. I just need to move this up a little bit. What we're going to substitute into, or what we have to actually substitute. Can we replace angle 2? Yeah, we can do that. We're going to replace it with 60. We just figured out down here that the angle 2 is 60. Likewise, with angle 7, I can replace that. I'm trying to determine what angle 4 is. I'm not going to replace that. In the same way, I'm not going to replace what angle 9 is. But can I replace angle 8 and angle 3? I can't handle this many unknowns. I need to have a replacement for those. Well, look at your diagram. Yeah, I think you can. You're told something about angle 3 and it's told something about angle 8. We didn't mention this in our givens, but it's something that we can probably go back and fix right now. We're told those are right angles. And by definition, what it means to be a right angle, that means they measure 90 degrees. So let's kind of use this as this remaining space to actually write a third given. Uh, the measurement of angle 3 equals 90 degrees. In the same way, the measurement of angle 8 equals 90 degrees. And that's just because of the definition of what it means to be right angle. Definition of a right angle. Which is a necessary part, and it was actually part of our given statements. This is something that we kind of overlooked in our first step. It becomes necessary now because when I go to do my substitution, I'm going to need those actual values. So using this step, let's replace what we know we can replace. Instead of measurement of angle 2, instead of the measurement of angle 2, let's use a value we actually found, which is 60 degrees. Instead of the measurement of angle 3, let's use 90 degrees. And the measurement of angle 4 is what we're literally trying to find right now, so we're not going to replace it. Let's do the same modification to the second equation. The measurement of angle 9 was found, excuse me, what we're trying to find. The measurement of angle 8 is up here, it's 90 degrees. And the measurement of angle 7 was found in this step, and that's going to be, excuse me, in this step, and it's going to be 60 degrees as well. Okay, so in terms of why we're doing this, it's going to be because of substitution. Okay? And where the idea is coming from, well, we got to be careful here. Now, we're certainly modifying these equations, so I can draw a single arrow here because we're changing them. I would also argue that we're getting the values from our previous purple step and from our new given. So there's three ideas converging there. Now, in terms of substitution and solving, I'm not going to show the steps. I'm just going to go ahead and write the final value. The measurement of angle 4 is going to be 30 degrees. Likewise, the measurement of angle 9 is also going to be 30 degrees. And that's just going to be because of solving. I'm going to write up to the side here. Now, in terms of where the idea is coming from, I'm just modifying or solving the equation above it, so a single arrow would suffice. All right, so let's figure out where we are. We just figured out that that's 60 and these are 30s. We're almost there. All we had to do is maybe use angle addition right here one more time, and we're going to be really good to go here. In fact, it seems like I'm going to use the same argument I did in the purple step, just the values are going to be changed around a little bit. So looking at our diagram, in fact, let me do this really fast to make life easier for us. Where is my camera? Oh, it's up here. Okay. Bear with me. I apologize for the delay. Okay. Okay, so again, I apologize for that. So I just want to make sure we can see the picture here. So we need to figure out 5 and 10. Well, it looks like we're going to go the complementary kind of angle addition route, I think. Um, so these are complementary. These are complementary. It's going to look like our purple step here. We're just kind of writing it with different angles. So okay. So let's go to this angle first. It seems I can claim that angle 4 and angle 5 are complementary, and angle 9 and angle 10 are complementary. And that's going to just because that's what it means to be right angled. So because the definition of a right angle. Okay. Now that again, the idea is not coming anywhere. The idea is coming from somewhere. Excuse me. Just like the green step, we have a combination of two ideas. This one being the angle addition idea, and this one coming from definition of rectangle. Or actually, you flip those. Okay. If they're complementary, that means I can write some usable relationship equations. The measurement of angle 4 plus the measurement of angle 5 equals 90 degrees. The measurement of angle 9 plus the measurement of angle 10 is likewise 90 degrees. Okay? And that comes, and I'm just going to copy it from here, that's because the definition of what it means to be complementary. That comes from the previous step, so a single arrow, again, seems appropriate. Now let's do some substitution. I mean, we're trying to solve for 5 and 10. We got to show the measurements are the same. We got to modify the equations we currently have. So we need, in other words, we need to replace angle 4 and angle 9. But luckily, we know what those values are. We found them in the red step. So replacement, 30 degrees plus a measurement of angle 5 equals 90. 30 degrees plus a measurement of angle 9 equals 90. Okay, and that's because of substitution. Where's the idea come from? Well, certainly the one above it because we're modifying the equations. And of course here because that's where we're grabbing our values. Um, I can solve this now. Now that I have the relationship that's substituted, now I can actually solve it. And I can show the measurement angle 5 equals 60 degrees. And likewise, the measure of angle 9 is 60 degrees as well. And again, my reason, my because, is just because of solving. So I'm solving the one above it, hence a single arrow. Now we're not done because I had to prove they're congruent, but you know what? If the measurements are the same, by definition, they are congruent. So I can just claim measurement angle 5, excuse me, is congruent to angle 9, because the definition of of definition, excuse me, of congruency. And that is the end of that monster proof. I'm gonna put a little square there. That's how we're gonna note the end. Um, so again, lots of steps. I mean, there's a lot going on here. Right? There's a lot going on here. I mean, in general, what you have to kind of realize is that there's lots of steps, but really only three big chapters. We use complementary angle addition to get the first set, triangle to get the second angle, complementary to get the third. Mirrored over here, complementary first, an angle addition, triangle second, and then the angle third. So let me zoom back in here. I'm going to do one last slow pan because this was a fairly long process. Okay. Okay. So again, please at your leisure rewatch this, study it. Guys, I'm fully aware how complicated this is, but I do have high confidence you guys can do it. It's just explaining all your steps. Just think of it like that. The format, you don't have to follow mine. I'm simply showing you one of the formats. So that concludes this part of the proof.